Hi guys, I am currently going to go through the chapter 10 notes. Sorry, they're a little crumpled in front of me. You guys have the shiny Google document. All right, so chapter 10, section 1 notes. If you have your stuff from school and you're organized, you may have a way to save yourself some time. So this chapter is kind of all about the basics of chemistry, okay? This particular section is called classifying matter. So there's a ton of vocabulary here. The word matter is anything that has mass and takes up space. And I'm going to use everybody's favorite word to describe this, stuff. Okay? Then we can further classify matter into the different kinds of atoms it comes in. Okay? So an atom is the smallest building block of matter. Okay? It has a middle called the nucleus, and then around it, it has something called an electron. Okay? Inside of an atom, the center again is called the nucleus. Okay? In the nucleus, there are something called protons, which have a positive charge. And neutrons, that's an O, which have no charge or are neutral, hence the name. Okay? Then going around the outside are these electrons. Okay? They have a negative charge. And they move really quickly around the nucleus. Okay? Not all atoms have the same number of protons, neutrons, and electrons. In fact, the number of protons tells us what kind of element, or what kind of atom, let me use that term, you have. Okay, so every different kind of atom is called an element, and every different element has a different number of protons. Okay, much more on that when you get to 9th grade. Substances. A substance is matter with a composition that always stays the same. The example I used before was water. Okay, its composition is H2O. 2 hydrogens for every 1 oxygen in a molecule of water. Okay, one type of substance is called an element. And I just talked to you about this again. It's one type of atom. So if you think about Legos, all the different kinds of Legos that you have in your Lego bin are all the different kinds of elements. Okay? Each type of atom contains a different number of protons. Okay? The number of protons is called the atomic number. Of the atom. Okay? Most elements consist of individual atoms, but the atoms of some elements exist in groups. Okay? So an example of this one would be oxygen. We don't really find oxygen all by itself. We find it as O2. Oh, we can't see. I gotta move the camera. Here we go. Ready? Just like in school, right? Okay, there we go. That's better. So we don't find oxygen by itself. We find it bonded together. Okay? That's the way your body uses oxygen. It's more stable that way. Okay? A compound is a type of substance containing atoms of 2 or more elements that are bonded together. Okay, so an example I'm going to use here is salt, the table salt you have on your popcorn, for example. Okay, so salt is made of 2 elements, sodium and chlorine. Okay, so its chemical name is sodium chloride. Okay, those two elements are bonded together, and when they're bonded together, they form a compound called salt. Okay? A chemical formula is the combination of symbols and numbers that represent a compound. So this is a chemical formula. This is also a chemical formula. Okay? It's the letters and the numbers. Okay? The symbols in a chemical formula show the different elements, and the number shows you how many. Okay? So we write the numbers underneath, which is called a subscript. Okay? The example I gave you guys before was C6H12O6, which is sugar, the kind that's on, cookies and everything else. Okay? This is a subscript. It happens below the line. Okay? Sub like submarine. Okay? Sub again means below. Everybody right with that one so far? Okay. Let me adjust so we can see the other side. If no subscript is written, okay, so like in my example of NaCl, right, sodium chloride table salt, like this, no numbers, okay, we assume that only one of each atom is present, okay, and that's exactly how salt works. The properties of a compound are different from the properties of the element it contains. So example, sodium chloride. Sodium is a metal. It's soft. It kind of has the consistency of cream cheese. It's super reactive, and if it was in the air, it would actually be sparking and catching on fire. Okay. Chlorine is a toxic gas. Okay. It's green. It's yellow. It's not a good scene. Okay. If I combine the two of them together, I get a white powder that tastes great on your food. Okay. So when I chemically combine things, I can't predict the quality of the thing based on what it's made of. Okay? Mixtures. A mixture is matter that can vary in composition. So up until this moment, we've only been talking about things that are one item, a substance. Okay? Now we're going to take more than one substance and we're going to mix them together. Okay? They can be different compositions, so I can't just write a formula down for a mixture, okay? The components of a mixture are physically combined, okay? So that means I can separate them physically, okay? Some ways I can do that would be like, if I had a mixture of salt and pepper, I could pick it apart. Wouldn't be fun, but I could. I could use a filter to filter out big and small particles, okay? I could boil water away. There's all different ways that I can separate a mixture physically, but I still end up with all of the parts, okay? The amounts of different components of a mixture can change or vary from one sample to another, and I've talked about Kool-Aid before, right? Some people make it really strong, and some people make it not so strong, okay? All right, so that's an example of a mixture. Now we have, look, it's just like school. I have to constantly change my camera. All right, so here we have the different kinds of mixtures, okay? And you'll learn much more about this in 9th grade, so try not to stress too much about it. The first one is called a heterogeneous mixture. This word here, hetero, this prefix, means different. Okay, so in this kind of a mixture, I can easily see all the different parts. So an example here would be salt and pepper. Okay, if I had salt and pepper mixed together, I would easily be able to pick out which parts are salt and which parts are pepper. Okay, the other kind of mixture is called homogeneous. Homo means same. So in a homogeneous mixture, the parts of it are evenly mixed and I can't see the different parts, okay? There's another name for this. We call it a solution, okay? This is not important, okay? But it would be solute and then solvent. Okay, so sometimes you say, there's a can of solvent over there in the garage, and then you use it to like get the paint off of something. Solvent is usually the liquid part of the mixture. Solute would be the powder or the other chemical that you mix in. Okay, when something dissolves, it forms a solution by mixing evenly. Okay, so Kool-Aid is an example of a solution. I can't see the parts. Okay, I mix the powder Kool-Aid in the water, the solute in the solvent. Okay, but I could, if I really, really wanted to, separate it by boiling. Okay. All right, so then we have compounds versus solutions again. So now I'm comparing the two things at the same time. I can use a formula to describe a compound, but not a mixture. Okay, the components of a compound are chemically combined, which means I have to do a chemical reaction to separate them. But the components of a solution are physically combined, so I can separate them without changing what I have. Okay, the composition of a solution can vary, like Kool-Aid, but the composition of a compound is always the same. So salt and sugar are always made of exactly the same things in the same parts. Okay, so now fill this out in your Google Doc. Okay, turn it in, and that is assignment 1 of week 1 of required work. Okay, the second assignment is all based off of this knowledge. Okay, and they're all the worksheets. Miss you guys a lot. See you very soon.